guys, so today we are going to be learning how to balance chemical equations. Last class period we learned how to count different atoms, and now we're going to put it all together into balancing. So we have a problem here. We have H2 plus O2 goes to H2O. The first thing that I want you to do is we need to separate the reactants and the products. So we're going to draw the dashed line . Separating them. Then we need to go ahead and we need to label them. So on the left-hand side of our equation, this is going to be our reactants. On the right-hand side is our products. So we want to start off, after we've labeled products versus reactants, I want to start off by doing what we call the bubble method. Okay, so what we're going to do is we're going to draw bubbles to represent each one of these compounds up here. So the first one I have is H2. So I'm going to circle it. And instead of writing H2 in my bubble, I'm going to write out both H's because I have two H's. So I'm going to put two H's there. Then I'm going to grab and go to another bubble. And this time I have oxygen. So I have two of them, so I'm going to put two oxygens here. Now I'm going to do the same thing on the other side with my other compound. Do our bubble. We have H2, so H. It didn't change colors for me. I like to keep things color coordinated so it's a little bit easier to see. So two H's, and we have one O. So the whole thing about being balanced is the fact that we want the same number of atoms on the left-hand side, or the reactant side, as we do on the product side. So we're going to go ahead and we're going to start counting. So if I look over at the reactant side, I see that I have two hydrogens right here. Whereas on the right-hand side, or the product side, I have two hydrogens as well. So those guys balance each other out. Now I move on to my next element. My next element, I have an oxygen here and an oxygen here. So I have two oxygens here and only one on this side. So I need more oxygens on the product side so to balance out my oxygens. In order to do that, I'm going to have to add another bubble. When we add bubbles, we can only add whole bubbles. We cannot add partial bubbles. Because if we try to cut a bubble in half, then the bubble would pop. So I'm going to go ahead, I'm going to add another bubble on this side. Put in my hydrogens, two hydrogens, and one oxygen. And I'm going to count my oxygens again to see if they're equal. I have 1, 2 on the reactant side, and I have 1, 2 on the product side. So they're good. Now I've reached my dotted line that I created. So I need to go back to the beginning and make sure that everything is still balanced. On my reactant side, I have 1, 2 hydrogens. On the product side, I have 1, 2, 3, and 4. So they are not equal. I need more hydrogens on the reactant side, so I'm going to add another bubble of hydrogen. And I'm going to count. I have 1, 2, 3, 4 hydrogens on the reactant side, and I have 1, 2, 3, 4 hydrogens on the product side. Double check to make sure the oxygens are still balanced. 1, 2 on the reactants and 1, 2 on the products. I have the exact same number of hydrogens and oxygens on both sides of my chemical equation. So now I need to come up with my coefficients. So I count my bubbles. I have 1, 2 bubbles here. So the coefficient is going to be a 2. I have 1 bubble here. So the coefficient is a 1. And I have 1, 2 here, so there's a 2. And now the reaction is balanced. I do want to point out, though, that you do not have to have a coefficient in front of O2, because you don't have to write the ones. Right? You can if you like to, but you don't have to. Moving on to our next equation. We're going to start off the exact same. I'm going to start by dividing my reactants and my products. Label the reactants. reactants. And label our products. I'm going to go ahead, I'm going to start drawing my bubbles. So on this side, we have AL, and there's only one of them. We have BR2, so BR, BR. Go to the next side, create a bubble. We have AL, and this time we have 3 BRs, so BR, BR, BR. Okay. And now we start counting. I look at my aluminum. I have 1 aluminum on the reactant side, and I have 1 aluminum on the product side, so it's good. I got a bromine. I have 1, 2 on the reactants, and I have 1, 2, 3 on the product side. I have less bromine on the reactant side, so that's where I'm going to add a bubble first. So I'm going to add a bubble here, and I have BR and BR. And we count again. So on the reactant side, I have 1, 2, 3, 4, and on the product side, I have 1, 2, 3. This time, I have less bromine on the product side, so that is where I'm going to need to add a bubble at. AL, 3 BRs. Again, go back and count my bromines. I have 1, 2, 3, 4 on the reactant side, 1, 2, 3, 4, 5, 6 on the product side. They're still not balanced. I still have less on the reactant side, so I need to add another bubble on the reactant side. We put BR, BR. And again, I count 1, 2, 3, 4, 5, 6 BRs, 1, 2, 3, 4, 5, 6 BRs on the product side. So those guys are equal. Now go back to the beginning and make sure that your aluminums are still balanced. I have 1 aluminum on the reactant side, and I have 1, 2 on the product side. They are not still balanced, so I need to add another bubble over here on the reactant side. AL. So I have 1, 2 ALs on the reactants, and I have 1, 2 on the product side, so they're good. Check your bromines again. 1, 2, 3, 4, 5, 6 on the reactant side, and 1, 2, 3, 4, 5, 6 on the product side. Now to get our coefficients. We have 1, 2 AL bubbles, so we have a 2. We have 1, 2, 3 BR bubbles, so 3, and we have 1, 2 aluminum bromide bubbles, so we put a 2 here. And our equation is now balanced. Moving on to our next problem. Always starting the same. Separate the reactants and the products and label them. So here's my reactants. And here are the products. So let's start drawing our bubbles. We have NaI over here. So NaI. And then we have a bubble of chlorine, Cl. Then we have sodium chloride on the product side. Sodium, and then chloride, Cl. Then we have iodine left. So let's start counting and adding our bubbles. On the reactant side, I have 1 sodium, so we're good. On the product side, I have 1. They balance each other out. On the reactant side, I have 1 iodine. And on the product side, I have 2 of them. So since the reactant side has less iodine, I need to add a bubble on the reactant side. And I count my iodines. I have 1, 2 iodines on the left, and I have 1, 2 on the product side. So they're good. Now I'm going to move to my chlorines. So just keep moving right. I know that you can probably see that my sodiums aren't balanced, but we want to move from left to right. Never backtrack, because if you backtrack, you usually end up missing something. So since I just did iodine, I'm now going to do chlorine. On the reactant side, I have 1, 2 chlorines, and on the product side, I have 1. So since I have less chlorines on the product side, that's where I need to add my bubble. So adding sodium chloride. I have 2 chlorines on the reactant side, 2 chlorines on the product side, so they're good. Go back to the beginning and make sure everyone is still balanced. We have 1, 2 sodiums, and we have 1, 2 sodiums here. I have 1, 2 iodines on the reactants and 2 iodines on the products. Then I have 2 chlorines on the reactant side and 2 chlorines on the product side, so it is balanced. So we just need to go ahead and add in our coefficients. We count 1, 2. So a 2 in front of sodium iodide. We have 1 for Cl2. So I'll put a 1 here. Remember, you don't have to write them. I have 1, 2 in front of sodium chloride and 1 in front of iodide. And we have a balanced chemical reaction. Just a couple more, and then we'll be good. All right, so separate the reactants and the products. On the reactant side, we will label it. And then we'll label the product side. Now we're going to start with our bubbles. So this one can get a little long. So just make sure you're doing it on a spare sheet of paper. We'll start here. So I'll start with my carbon. I have 3 carbons, and I have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, and 8. Now I have my oxygens. I have 1, 2. Go to the product side. We have carbon dioxide, carbon. 2 oxygens. And then we have hydrogen. We have 2 hydrogens and 1 oxygen with our water. All right, here we go. On the reactant side, I'm going to start with my carbons. I have 1, 2, 3 carbons on the reactant side, and I have 1 carbon on the product side. So I need to add more bubbles to the product side. So add 1 will give me 1 extra carbon. But my reactant side has 3 carbons, so that means I'm going to have to add another bubble to this side, to the product side. So carbon with some extra, some more oxygen. So now I have 1, 2, 3 carbons on the reactants and 1, 2, 3 carbons on the product side. So we are good. Now we go to hydrogen. On the reactant side, I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and on the product side, I only have 2. So I need to add more bubbles. I'll add a bubble here. When I do that, it gives me 4 hydrogens. But I need 8, so so I'm going to have to add some more. Add another bubble. We have 5, 6. But again, we want 8. So we have to add another bubble. Count your hydrogens up. You should have 8 on the reactant side and 1, 2, 3, 4, 5, 6, 7, 8 on the product side. So they're good. Moving to my oxygens. I have 1, 2 oxygens on the reactant side. And I have 1, 2, 3, 4, 5, 6. But don't forget, I have oxygen in my other bubbles. So I have 6 there, 7, 8, 9, and 10. So I have 10 oxygens on the product side. So the reactants have less, so I have to add more oxygen bubbles. I add a bubble. I started with 2. I'm trying to get to 10. 3, 4, 5, 6. 7, 8. 9, 10. So I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the product, so they're good. Go back to the beginning of the compound or chemical equation and make sure they're still balanced. I have 1, 2, 3 carbons on my reactant side, and I have 1, 2, 3 on the product side, so they're good. My hydrogens, I have 1, 2, 3, 4, 5, 6, 7, 8 on my reactant side, and I have 1, 2, 3, 4, 5, 6, 7, 8 on my product side. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everything is balanced, so we need our coefficients. We have 1, 2, 3, 4, and 5, 5, 1, 2, 3, 1, 2, 3, and 4. And that's our balanced chemical equation. We have one last problem. It's a little bit more challenging. But we're going to follow the exact same steps. Okay? Separate the reactants and the products. Label them. This side is your products. Alright, now let's get creating some bubbles. Alright, so the first one I have is magnesium hydroxide. So I have 1 magnesium. Now here's the trick. When you have polyatomic ions, you want to keep the polyatomic, you want to try to keep the polyatomic ions together if you can. Alright, so if you notice, we have PO4 on this side, and PO4 stays together. We have OH here on the reactants, and we have H2O, which is just the same thing as OH, but backwards on the product side. So we're going to write it out as one thing. Okay? So we have hydroxide, so OH and OH. Then we need to go ahead and do our next one, which is H3PO4. So I have 3 hydrogens, and I have 1 PO4. So PO4. Go over to my product side. write out our hydrogens. Well, I kind of messed that one up. Let me go ahead and color code this one over here. I'm sorry, guys. I'm going to make these hydrogens blue because I think it's going to be a little bit easier for y'all to see it this way. Okay. So that's on me. Okay. So 2 hydrogens, and we'll do 1 oxygen here. And we're going to do magnesium phosphate. All right. So that's 3 magnesiums. And I have 2 PO4s. So PO4. Yeah, I'm sorry. I should have kept the hydroxide a little bit separate because it's a little bit easier for y'all to see. But now we're good. We're set up good and we should be able to go. So let's go ahead and we'll start counting. So on the reactant side, I have 1 magnesium. And on the product side, I have 1, 2, 3 magnesiums. So there are less magnesiums on the reactant side. I only have 1 where there's 3 on the product. So I'm going to end up needing 2 more. So I'm going to go ahead and draw 2 more bubbles. We have magnesium and magnesium. And we have 2 hydroxides. Hydroxide might be the only one that you don't want to keep as a product. Okay, so that's my fault. So we have 1, 2, 3 magnesiums on the reactants and 1, 2, 3 magnesiums on the product side. So we're good. Let's go and let's count our oxygens next. We have 1, 2, 3, 4, 5, 6 oxygens on the product side, and I only have 1 oxygen on the reactant side. So let's go ahead. To make them equal, if I have 1 versus 6, I need 5 more on my product side. So I'm going to draw 5 more bubbles. We have my H's. All right, so we are good. Now I want to go ahead and move on to my next compound, which is H3PO4. I do realize the first thing that we have on this side is hydrogens, but I'm going to kind of wait on my hydrogens for a second. No, I'm not. Let's go ahead and count these. All right, so count my hydrogens. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens here. Which means I need to add more hydrogen. And I'm going to add it. I'm going to add more hydrogens to the reactant side because that's where I'm missing one. So I'm going to add a bubble. We have 1, 2, 3, and then our PO4. So go back and count your hydrogens. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on my reactant side, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my product side, so I need one more bubble. Okay. And now I should have 12. Then I'll look at my PO4s. I have 2 PO4s on the reactants and 2 PO4s on the products. The Go back to the beginning. Let's make sure everything else is balanced. On the reactant side, I have 1, 2, 3 magnesiums. On the product side, I have 1, 2, 3. On the reactant side, I have 1, 2, 3, 4, 5, 6 magnesiums. And on the product side, I have 1, 2, 3, 4, 5, 6 oxygens. Then my hydrogens, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the reactants, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on my products. And then the last is the phosphates. So this one is balanced. All I need are my coefficients. So I count 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, and 6. And then just 1 for that one. And then we're all good. So this is how you balance chemical equations.